Okay, everyone. Nice to see you all here this afternoon. I know myself and James are on fairly late in the afternoon, so we'll try and keep this upbeat and keep you going. What we're talking about this afternoon is actually how I've worked with James and his team to actually make use of these tools which you've been hearing about. And so we've taken something from being theory to actual practice. So my name's John Forster, as you can see on the screen there, and I'm currently contracting with a company called Fitness First. Hopefully some of you have heard of Fitness First. They spend an awful lot of money to try and make people know about the company. And what am I telling you about this afternoon? It's really this step change which Fitness First have made in terms of, one, how they host, but really the key thing today is what we've done around the pipeline of the code which we write. All of the systems which we use to manage all of the membership and do all the payments and do all the bookings and do all that, great stuff, we write all of that in-house. So what I'm going to take you through today is how we've made that real step change move from a very manual process to an automated process. Also to move to have standardization, as I call it, as the norm. So it's pretty close, it is the same. And that's the big change which we've made. And also we've made a big change in the tool set which we use. Previously there was some in-house developed ways to push out code, to manage this and to manage that. But when you take a step back and you look at it, you're writing code to manage code and what you're really playing at. There's some really good tools out there. Pick the right ones, put them in and make them work. So really, very briefly, because I don't work in marketing, this is not a marketing slide. Just to give you some idea of scope, Fitness First, there are a bunch of gyms where you go and try and get healthy. We're across 16 countries, UK, Germany, several over in Asia, over to Australia, several over, basically we're spread around the clock. So we're open all of the time. There's some club open somewhere all of the time, and some of our clubs are open pretty much all of the time anyway. And we've got about 1 million members, so there's a fair amount which we've got to deal with. So what's the journey which we've taken? As you can see here, what the business was saying is that we want consistency, so we know it keeps working. We also want to have a much faster movement from concept to actually being out there, because it did take far too long. Someone would have an idea and it would be 3 months, by which point the industry's moved on, the business has forgotten why they wanted it in the first place. We wanted to reduce the cost, which everyone wants to do, but we really wanted to do that. Really key, we wanted less errors. Every time code went out, everyone crossed their fingers. And when I said, has code ever gone out and just worked? Everyone sort of looked a bit sheepish at that point. So the strategy which I worked with them to get to say, right, we want an industry-leading tool set. We don't want to play around with all these little bits of toys. We want the correct things. We want standardization all the way through. So I said, with 16 countries, you end up with an awful lot of code and an awful lot of databases. I want to move to automation, move away from people doing things at 3 o'clock in the morning, want to simplify it. Tied to that, I want less moving parts, which was to shrink down the amount of tools which you've got and again have the right ones. And really key as well is transparency all the way through. So everyone knew where things were at all of the time. So quickly going through this slide, as part of this, also had to look at what hardware we had, where it was. So at a data center over in Holland, old physical hardware, 18 racks of kit, awful lot. Windows 2003, SQL 2005, a bespoke tool set, be a nice way of putting it. Manual, slow, and old technologies. So where we've moved to is hyper-converged hardware. So we don't have a SAN anymore, gone in the bin. We had about 5 of them, they've all gone. So hyper-converged hardware, we made that step up to the latest Windows. We do have this industry-leading toolset, I believe, in place now. I'm pretty sure it is industry-leading because they're actually now saying it's classed as R&D and I can get the tax back on some of it, of what we've done. And getting money back from the tax man is always a good step forward. Key as well is moving to this DevOps process. And again, that's a step change and using the modern technologies to do that. So those 18 racks of kit you see there on the left-hand side, we're actually now down to 2 half racks. And that's everything in there. And we've done this by shrinking down the hardware, bringing in completely new kit, and working with the DevOps guys to get to where we are. But this is a challenge because downside of having old kit and old technologies is that the team is used to working with old kit and old technologies. So if you want to do a step change, you're bringing in new technologies, you're bringing in new skills, and the business said, can you get on with it? So what we needed to make this happen is a trusted partner, is someone who can get on and do the work, and also can bring us not 1,000 options, which was really positive to see, which the tools, when they were brought in, working with this company, is because they didn't say, well, you could do this, or this, or this, or this, or this. And I said, I really can't answer the question. You know what I want at the end? Just get there. You tell me the answers. If you get really stuck, give me a choice or two. And the right tool set. So what do we now have in place? It's definitely simplified. There's an awful lot less moving parts. It's a lot more flexible. Before, if we needed a new environment, if we needed a new service, standing up, 3 weeks. Now it's 30 minutes. Much better total cost of ownership. So the finance people are a lot happier. We spent quite a lot of money, but we've saved so much money. It is much faster. It is much more controlled. And the automation, the guys in the team are still getting used to the fact that we could just push code, the database, everything out, flatten everything, rebuild it all again, and they just watch it happening on the screen. It's such a step change for them. It's such a way they're going, and it's the same. And I said, yes. So they tested in one environment, and they said, well, don't we need to test in the second one? I said, no, because it's exactly the same. If it works there, it'll work there. You can test it if you want, which they did the first time, and then they realized it was exactly the same. So what we brought in, and it's a benefit sometimes of moving from really old kit, is that we did throw it all away. We didn't take anything across. So we moved to Azure, we host, we DR over to the cloud, we also host in the cloud, changed SQL, gone to Hyper-V across the board, Team City, Octopus Deploy, Redgate, I think you recognize the one in the middle there. All these other ones in there, that's what we've ended up with. That's our tool set which we've got. And on the way, we did drop an awful lot of other stuff. We just chucked it. So that this pipeline, and this is a really key thing, this is where we've really made this step change. It's an overall picture of what it looks like. So you've got your dev people on the left. As you can tell, I wear a tie. I can't be a dev person. But there's a dev people on the left. They're managing everything through source control. It goes into Team City, and then it releases through. But you know all of this stuff. But this is where we've actually ended up with. This is what we've had working with good people to actually build. Now, one of the challenges which, when I first met James and his team, right back at the start, which is actually not that long ago, we've only been working together about 6-7 months. So you can do things quickly if you get on with it. This was one of the key questions I put to him right at the start. Not to challenge him, this was actually the problem. We have 3 branches of code. We'll have one running in production. We'll have another 2 being put together across 16 countries and having to look after them all. Same common code base underneath. So it's the same overall database sitting there underneath. How is that all managed? And I said, look, The only way we can get this to work is if you can do this. If you can't do this, then we're pretty much back at square one. So that's explained of where we've gone to, how we've moved. We have moved very quickly. So if I hand it over to James, then he'll explain far better than I can how it actually works.
Cool. Thanks, John. Good afternoon, everyone. I'm James Smith. I'm co-founder of the DevOpsGuys, and as you've heard with John, we've been working with Fitness First for about 6 months now. Lots of challenges, lots of interesting things, and it's useful to go back and maybe just refresh kind of like why we were doing this, I guess. So, we were posed with this problem of we want to get change to market quickly. We live in a society today of I want it now. And that's true of consumers, but it's also true of business. You have 1 million members coming into gyms. They expect these systems to work 24/7, 365. And also they want to be kind of, looked after and cared for. And the business need to react to some of the changes and feedback that they're hearing from their consumer base. But trying to deploy those changes really quickly all of the time means that sometimes the costs can increase. So we're trying to get faster, but we're also trying to simplify and bring the costs down. And most importantly, we want to drive this standardization. That has a whole range of benefits. It simplifies everything. It reduces the training overhead. It brings in best practices. But most importantly, if you had standardization, it creates this opportunity inside organizations then to innovate. So there were some challenges, running across 16 different countries, which all require different setup and data and configuration in production, was quite hard. The data is there for operation. We've got different members in every country, production data, but we also have different setup and configuration for testing. So when we go into organizations, we start to look at how software is delivered, and we kind of see the world in this kind of 7 stages. Right from how do the business kind of come up with the concept and the idea, to how do they make cash from it. So from plan right through to operate. And there's a whole series of steps in between, and today you'll have heard of some of these concepts: source control, integration, and so on. And this is one of the maturity models we use as we look at organizations. So we go from top to bottom in terms of maturity, the bottom being kind of okay, the one at the top being better. And this is based on a model that was put together by Jez Humble and Dave Farley in their book, Continuous Delivery. And the one we looked at, kind of in context today, was the data management. So at the bottom, if you can see it, it says everything's done manually, basically. And that means that you kind of, as an organization, you're slightly regressive in your process. Life could be better. To the top, where pretty much everything is kind of optimized, and you're trying to just increase the capability that you have day in, day out. You're not firefighting anymore. You've moved past that. So in the maturity that we looked at, when we talked to Fitness First, life was good, right? Automated unit and acceptance tests everywhere. High coverage, something like 80%. Testing was part of the development process. It wasn't kind of a big UAT handoff. They were running 2-week iterations, and in that 2-week iteration, they were doing testing. Okay, it wasn't kind of, hey, we're agile, but we're doing a waterfall dev process. And changes were performed automatically. They had DB scripts. They were rolling them out through their bespoke tooling. So life was good. Level 1 consistent. Big tick in the box. Hey, aren't we brilliant? But there's a but. And the but was significant. When we actually started to peel the layers back around this testing process, we discovered that there were a few challenges. And I think brittle is the word that we came up with. So let me tell you why. Well, the integration tests, first of all, involved taking a binary backup of a database and putting that into source control. Now that was interesting to start off with, because they were initially using SVN. And one of the nice things Git have done originally is to limit the file size, so you can't take massive binaries and stick them in source control. Is that a bad thing? Well, let me walk you through this. So we restored that database out and created an integration test that had this static set of data inside it that was going to drive the regression test suite. But it was out of date. and it didn't look like the database that they were trying to test against. So we had to patch it. So we run a whole series of changes and upgrade scripts to not only the schema, but the data. And then it was ready for testing, and we executed the tests, and we got some results back. And it wasn't too bad. I was like, okay, I'm not really happy with binaries in source control, not really happy with the restoration process, but it's not kind of too bad. And then we took a look at the regression tests. So we had a test database per country. So we don't have 4 of them, we had 16. And then we looked at how this was being tested, and there's kind of 3 kind of major feature toggles in some of the databases. So we had 16 databases in source control that were being reconfigured to a 3-to-1 ratio for these feature tests. Anyone guess what could happen next? So we started to get more and more databases. And then we had to patch them all, one after the other. And we thought, okay, this is quite expensive. When we look at where the time is going on in our build process and our deployment, we're now not in kind of minutes of build time. We're starting to get close to, tens of minutes and close to hours. And then they threw this curveball in and said, hey, that's awesome, but we've kind of got 3 branches. We've got some countries that we haven't upgraded yet, so they're running kind of version 1. We've got some countries ready to go version 2, and we've also, in some of the development environments, we've got version 3, which is kind of the next version ahead. So we took some feature tests, and then we expanded out into the databases for regression, and then we layered in the branches, and we ended up with 128 databases just to execute a set of regression tests. And then we patched them all. And it's kind of like, wow, okay. So a single change to any line of the code or any database now required hundreds of databases to be restored and patched. And we had absolutely no idea what was going on across them all. Were they at the right versions? We didn't know. Was the data right? We didn't know. Development team really didn't have any kind of visibility. The test guys certainly didn't, because the changes were being committed by someone else. So our engineers did that. They went running, screaming away from the process. And in the background was this entire kind of catastrophic explosion of regression testing. So we definitely needed to come up with a new way. We had to pare it back and start to look at where some of these challenges existed. So we need to start at the foundation and look at source control and kind of work out where's the stem of the problem coming from. We know we've got these kind of database backups. We're not happy with that. But we've also kind of need to clean up some of the CI process. And then once we've got this thing in place, we need to kind of manage the release of these test databases. Now, what you'll have heard today is a lot of focus around patching production DBs and the things that are actually running your systems. So I think our view of the world, it's the same process, but we're putting a slightly different spin on what we've done. So as John showed you, we came up with a pipeline. And what's good about the pipeline is kind of the pipeline for deploying regression tests now and the production code was standardized. So the pipeline you see in front of you, it was used to deploy changes into production DBs, but it's also used to deploy the regression test suite to test the code that we want to deploy. So it's kind of a nice standardized framework. So to kind of fix this problem, we did 5 things. We want to reverse engineer these databases out of binaries back into their raw script form, stick those scripts into source control so we had a much better, clearer view of what was going on. It was really important that when we built these databases up, we built them from scratch, right? Repeatable process, one of the key tenets of continuous delivery. Inject the data that we want to test or use for testing into this clean database so that we know the state of the DB. And then we want to execute our tests, analyze the results, and most importantly, afterwards we don't want these things anymore. They're useless. They've done their job. We've got our results. We can take those away. We can analyze them. So let's tear all this stuff down again. So bringing Redgate's DLM into the mix brought us this tooling in a nice integrated suite of tools that kind of fitted into our kind of core strategy, fitted into that standardization model, you know, around this pipeline that we'd already started to put in for deploying application code and infrastructure code. So we converted those DB scripts over and put them all under source control using SQL source control. Really nice, easy process. We stored out one of these regression DBs, and then, as you know, follow the tool process to script these things off, put them under source control, and stopped storing binaries altogether. Nice, straightforward. We then brought the SQL CI tooling into Team City and got that integrated. This now gave us a capability to build these regression test DBs up from scratch. And in the integration test, we just needed one. So we started there, and it was a nice, clean process. Pull the source code out, build the database, you know, have it upgraded if necessary, have all that process automatically done, inject the test data in for us, and have this thing packaged, ready to put somewhere. And where it got put was inside a NuGet package into an artifact repository, and Octopus Deploy could then draw down the databases and deploy them out to any environment that we wanted. Now, the one thing that's probably a little bit different when you're using, you know, statically driven databases for testing is that we also put test data under source control. So now we could modify it, and we could see the modifications that were going to happen, and we could have a conversation about those things. That wasn't happening before. You know, one of the most important things that source control brings to the mix for the development community is that point of collaboration, that point to start a conversation. So it allows us to see which data was going to be in each environment and the configuration changes. And as we branched and merged these changes, we had a good story. And as I wrote this slide, it kind of dawned on me what I was saying. I was saying put data under source control. So I have to put this slide in afterwards. It's like, don't put user data under source control, okay? I'm not advocating this in any other scenario apart from when you know the stuff is static and you know what you want to do with it. So we talk about the schema being in there. We talk about static reference data. And we know those things aren't going to change, but I'm not advocating that you start scripting off your production DBs and drawing all that data back in, as I hope most of you will think, well, that's common sense. But I've given up understanding, making assumptions anymore. So we ended up with this kind of really integrated, really clear pipeline. Source control at the start, managed with Git, integrated tool set, and then a process of pushing these tools through. And the Redgate tooling, the DLM, really bolted in nicely to this process to provide a lot of value. In production, we were also using the DLM dashboard so we could get visibility of these changes flowing through, and that brought us kind of insight that, as we've seen in the keynote this morning, that insight of what's going on allowed us to kind of almost predict some problems before they happened. So we did realize quite a lot of benefits from the process. We got a really robust and repeatable process. We were able to kind of over and over again create these databases now from scratch. We brought the test management process down from a thing that was taking hours and hours to execute, mainly just restoring databases everywhere and patching every single one of them down to minutes. We were able to build databases up, have them deployed quickly, execute tests, tear them down again. And we kind of had a single set of source code to maintain. You can argue the point that there were branches of that, but we had a strategy that allowed us to have one view of these databases. And when we upgraded scripts one time, we didn't have to patch 128 databases anymore. We had to modify code once and let the configuration and the deployment process take care of all of the other kind of scenarios that we had. So testers now could make changes in a process that was no longer really brittle. It was clean. It allowed them to have conversations with devs about new features and make sure that the test data was in sync with the code, that we could commit these changes at a sensible point. And the whole visibility of the process kind of really increased substantially. And it gave us a single point from which to build with. So, it's kind of a core piece of this was to really standardize that process and bring it back into a central point that we could expand from. And I guess the end result of that was that we had kind of happy testers and happy customers. It really did kind of, bring a new way to support those requirements that John talked to you about. And I think overall we've seen some really solid benefits from the tooling. So it's kind of a high-level overview today of a different way to apply some of this. What I'd like to do now is kind of open up to questions and see what you guys think. So any questions in the room? Wonderful. Start here at the front.
Yeah, only a few minutes ago you were talking about injecting data into your spanning crisp into database.
Yeah.
And then you said, but we don't source control the user data.
Yeah.
So you inject your reference to that. How do you get your user data into?
So apologies for the confusion. So the static data that we're using to execute tests against is in source control. So that is kind of user data. It's not the operational data that's being modified in production.
Okay, so it's a relatively small amount of...
It's a subset of known data that the tests need to execute against, and that's what's scripted and injected, yeah. Yeah. Okay.
Did you have any challenges in a real-time situation with like the branches using the database, like tables and stored procedures? So like, when you're merging those branches back into the master, for example, that merging conflicts within app code is fairly okay. But if you have new tables which are in a branch but they're not in the master, that can be a bit more tricky.
Do we have any challenges around that? I guess, bringing changes across from one branch to another always needs thought and conversation. So I don't see that there is a difference between merging application code in and merging tables. It's a similar process. So you're layering something from one branch into another and then having a CI process that's going to pick that up and validate it. The tooling that you've got available to you with SQL Compare is bringing out those changes and is giving you good advice about whether migrations are going to be needed to changes that you've made. So there are multiple sort of catch points in the process now to get early visibility of things that you think could have a major conflict or a major impact on the system. Yeah, so if you rename a column, you split a column out, you can actually kind of have some of those things break your build, and then that build break is a point to start a conversation about how we're going to resolve that. Every change that gets merged from a feature back in needs some review. I would always recommend, if it's in a complex area, that you should peer review those changes. But it's the same kind of good practice that you bring to code merging that you should now bring, into the databases. It's code at the end of the day, and it should be treated the same.
In terms of testing, does it depend on volume or performance testing? Let's say if you have a small testing phase, your application for completely different ways from like 100 gigabytes or terabytes.
Yeah, so part of the process, we're able to use tools like SQL Data Generator to bring in and scale out those tables for load. Depending on the way your scripts are written, you can formulate those up to recursively inject multiple test data sets in. So it's an area that we're getting better at. Bringing performance testing in to build pipelines as kind of a first-class citizen, I think, is still an area that's maturing. And it's not just kind of volume testing, it's looking at soak testing environments as well, and having environments that are coming online dynamically with a specific purpose for what they're going to be testing. So we talked about regression testing environments, but what's good about this process is, you're standing an environment up in a very standardized way with a very similar, or if not identical, configuration set. And then the purpose of the testing against that is differing. So you may stand up one environment to do security testing. You can stand up a very similar but new environment to do performance testing and multiple sets of performance testing. Yeah. And this process becomes much easier because you've got the data under source control. You can see the volumes that are getting injected, or you can automate tools like the SQL data generator to do that for you. Yep. Yes. Yep.
Yeah, it's really good to hear a real world example. I was just wondering how your application code fits in with that particular process. So one of the challenges I've got is managing not just database code,
Yep.
but also .NET and some legacy Delphi code as well.
Okay.
How do you manage the whole code set together?
It's the same.
Exactly.
Yep. Same tooling. That's one of the beautiful things about kind of the way the DLM's been structured, is it's taking advantage of industry standard tooling. So whether it be, we use TeamCity, this is a Windows environment. In our preference, kind of in Windows-based environments, TeamCity is just a more natural fit to that. But it could be, Microsoft Release Manager, it could be Jenkins, it could be Bamboo, any of these CI tooling processes out there, and then feeding into Octopus Deploy. So you've got source control. All of your code is in source control. Okay, so if you're at a level where you're managing infrastructure as code, you have scripts in there that are controlling your infrastructure. Your application code's pretty much always been in source control, and your database scripts are in source control. So the build process around that can be very standardized now. You draw the code down, you build it, you perform tests, you package it, you make it available to deployment tools. And in the case of the pipeline we're looking at here, that deployment tool is Octopus Deploy. So that's drawing NuGet packages, whether they be for PowerShell DSC scripts to manage the infrastructure, whether they be database scripts to execute against the SQL server, or whether it be application code to put under IIS. The process of taking NuGet packages, moving them to a server, expanding them, configuring them, and having them execute is the same. And that's one thing about this pipeline, is it really does bring that standardization for every level of deployment. And even to the extent with Octopus Deploy that you can manage Linux environments, or have application code deployed into Mono, for example, and have it execute is similar. Yeah. More questions? No?
As a curiosity, are you,
Yep.
So you mentioned your environment scripts and infrastructure scripts. So are you actually in your CI? Are you guys creating the database packages and then maybe standing up an Azure instance and deploying all the stuff out into that?
We aren't in this example. It's going to environments that are kind of always on, so they're pre-configured. But with DSC, the scripts are being applied and then the environment's being enforced and monitored. We do have other examples where environments are being brought online specifically for that need, inside Dev and Test, stood up from scratch. So they're provisioned, configured, and then the application's deployed, and then tests are executed. So it is possible to do that. And typically the CI tooling at the moment is being adopted to do that orchestration piece, because there isn't much better tooling on the market to run that orchestration layer. So we're seeing kind of lots of that being shoveled into the CI process. What's interesting with some of the tooling coming from Microsoft, Build, vNext, and Release Management, they're now creating that orchestration layer that's kind of missing. So it'll be quite exciting to see what they release into the marketplace in the next few months. Yeah, I think it's in private beta at the moment.
Build vNext.
It's Build vNext, and it was called Deploy vNext, but I think they've renamed it Release Manager or Release Management. Yeah. It can be done at multiple levels actually. So source control is one obvious place. You can have peer reviewing going on there. You can bring in techniques like XP. So you got pair programming going on and peer review kind of as the changes are being committed. So pull requests, etc. inside Git. And then on the deployment side, also kind of manual sign-off steps inside Octopus Deploy. So any changes going out to a certain database or set of databases can have that manual kind of override step in them. And you're able to target that at specific groups of users. So as you deploy out to a SQL server, you have a targeted step that says, we want DBAs to come in, review these changes. You have the change sets available and the changes are being made, and then an approval process that allows those changes then to be rolled out to the target environment. So yeah, two levels essentially. Any other thoughts? No? Okay, I think we're not far off time, probably a little bit early. Well, there's quite a few people milling about. So, another question?
I was wondering, when you do something this transitional,
yeah.
These processes, how did you manage, or how did the team manage to continue doing business as usual and developing stuff? Did you have to take them offline for a while?
No, it's kind of a process of rolling elements of this in initially. So they had an existing pipeline that was deploying code out to production. One of the advantages we had here is because they'd made a decision to move into an entirely new infrastructure, we actually moved source control as well from SVN to Git. So we set up synchronization between the Subversion server and Git. We had changes flowing through the old process using the existing bespoke tooling onto the existing environments. And then those changes were being synchronized up into the Git environment, which was executing through the new environments, through the new tooling. I mean, it was a nice process in that sense because it gave us an opportunity to really validate changes coming through the new environment without having a significant impact on the development team. I think if we hadn't had that luxury, and I will call it a luxury, it would be taking subsets of this and doing it progressively. So you can't stand up the entire new pipeline. You've got to cherry pick which bits you're going to target first, get those rolled out and embedded down, and then take the next stage, really. Yeah. Yes?
You have two developers on the slides. So
Yeah.
How do you support concurrent development in this model? Do you have branching, or say developer one works in feature one, and
Yeah.
developer two works in feature two?
Yeah.
They both get checked in.
Yeah.
They all build fine, but someone further down the line decides, the business may decide that feature one is going live, feature two isn't. So at which point in this process do you take feature two out of the equation and only deploy feature one?
Yeah, so we're actually using Git flow as a branching strategy. So there's various different ways to handle that, based on kind of versioning and feature flagging, depending on what the nature of the change is. So we're able to take the packages stored in an artifact repository where we're able to target different deployments. So each of those changes is actually packaged up into a different version, and then you can target which versions. Because of the way the pipeline's integrated, we are able to understand which changes to source control have triggered which builds, and therefore which packages are associated, and then have those kind of individual builds targeted or deployed. The other thing is, if the changes are being made into a single kind of branch of the source control, having a CI process there that's feeding back really quickly about whether these two changes are going to work together and the impact is essential. So whether that be in the database or whether it be in the code, that fast feedback really does improve things.